So, I'm Gary Benson. I work for Red Hat. I work full-time on Gdb, the debugger, so that's my kind of context. That's where this talk is coming from. Infinity isn't kind of a debugger-specific thing. It's kind of it's for general software development tools. But please excuse me if I start talking about debuggers, and it's generally what I mean is software development tool. The slides for this are on infinitynotes.org/C16 if you want to follow it on your own screens or whatever. So yeah. Before I really talk about what Infinity is, I'm going to explain a little bit the motivation that's kind of brought it about. And that is that some libraries need to be understood by software development tools. And the example I'm going to talk about today is the one that kind of spurred the development of this. Is that the threading library libpthread provides functionality that allows applications to have multiple threads. And various software development tools, like debuggers, need to know that they need to understand threads. You're using a debugger, you want it to display a list of threads, you want to be able to switch threads, display information about those threads, whatever. So, and the way that libpthread is kind of understood by debuggers is it comes with a separate libpthread ships with a separate library, libthreaddb, which contains functions for looking inside libpthread for understanding the kind of internal data structures and in some cases modifying them. So, as a kind of diagram, this is what it looks like. You have your application up there on the left, and it's linked with libpthread. It's using it to handle its threading. And you've got a tool. Maybe it's a debugger. Maybe it's some performance monitoring tool or analysis. And that is accessing the application in whatever way that it's using. And because your tool has noticed that the application is using libpthread, it's loaded libthreaddb, and it's using the functions inside libthreaddb to understand what the application is doing with libpthread. And all the interaction kind of goes this way. There's no direct link between libthreaddb and libpthread. It all goes through the tool. Yeah, and already at this point, there's a kind of fair amount of knowledge that has to be baked into the tool to do this. So the first bit of knowledge is that software development tools need to know that if they see libpthread.so is loaded into the application, then the application is likely doing things with threads, and it's going to need to load libthreaddb to understand the application. Except libpthread may be statically linked. So even if you don't see, even if the tool does not see libpthread, it still has to load libthreaddb, maybe, if it's interested in threads. And this means that all tools that are interested in threading need to know how to find a suitable libthreaddb, which if your application is dynamically linked, then it can maybe use the path of libpthread.so to locate the libthreaddb.so. But if it's statically linked, you're going to have to choose some other way, which often breaks down to the user having to tell the application where libthreaddb is. And I also highlighted suitable there because they are separate libraries, they're separate files. You need to make sure that libthreaddb needs to make sure that the pthreads build inside the application that you're debugging is the right version, has the right data structures. And the present way this is done is just a string comparison of the version of glibc. So libthreaddb is going to find inside libpthread the string 2.24 or something like that, and as long as that matches, it's like fine, that's perfect, which is quite coarsely grained. And the other, there's kind of no standard way to do all this. It's just a pattern. So every tool that's using libthreaddb basically has to write its own stuff to, to decide whether it needs libthreaddb, to find it, and to call all the functions, whatever. And also a kind of semi-point is a libpthread is just one way that an application can have threads. It can just go straight to the kernel and do its own. Yeah. And these are all kind of issues, but they're all handled. They're handled today. GDB can handle, maybe sometimes in a clunky way, all of these issues. But if I go back to the picture we just looked at, it's not the complete picture, because all of these, all four of the boxes on the first picture, they're all linked back into the C library. So there's this kind of common connection between them, and that's fine if you have a modulus environment. It's fine if you're working on one machine, everything's linked to this one C library that's in the middle, and it's also fine if you're working on a cluster of machines, but they're all, they're all the same architecture, they're all the same operating system, they all have the same build of glibc on there. But it breaks down in at least two cases. It breaks down if your application is running on one architecture and your tool is running on another. It also breaks down if you're using a containerized environment, in which case the underlying hardware is the same, but there's no guarantee the operating system is the same. There's no guarantee it's even the same update level. So you have this situation with containers where your tool would have to, because libpthread and libthreaddb are built from the same sources, they're built in the same package, libthreaddb is going to be inside the container, which means your tool, if it wants to load it, even assuming these two C libraries are the same or compatible, your tool is going to be loading files from the container and loading them into its own address space and calling functions inside them, which is kind of a security risk, because generally in this situation the software analysis tool has higher privileges than the application that's running. You can work around things like the different architecture by cross-building libthreaddb. So you have say a libthreaddb that has PowerPC internal structure offsets and things, but it's built for x86-64, which is what your desktop is. But that way kind of leads then to a kind of n by n matrix of different libthreaddbs that you have to individually build and manage somehow, and it's kind of messy. So I'm going to say, what does libthreaddb actually do? So it exports some kind of fairly high-level functions, like give me this particular information about a specific thread, what thread is running on an LWP, and it has functions like I want to iterate over all the threads and call this other function back. And the other side of it is kind of like a bidirectional library. It imports some functions from its caller as well, but they're like lower-level functions. So it has functions like read me this block of memory or access these registers of this thread. So what's actually from the caller's point of view, from the debugger's point of view, the debugger is kind of handing control over to libthreaddb. It's saying, I need this information, just drive me for a bit. So then libthreaddb is like, what's this register, what's this address, and it shuffles it about, and then it gives the debugger or the caller, the tool, whatever it asks for. So the solution I've kind of been working on is to kind of store, instead of having these functions as kind of real, don't know about real, like machine language code in a regular library, to store some kind of platform independent functions, which basically do the same thing, but actually stored in the library that they're talking about. So actually finding the functions you want becomes trivial, because if the if libpthreads implementation is loaded into the application, then also these debugging functions are also there. The tools don't need to have this kind of thing where they know that if they find one library, then they have to load another library. It avoids kind of baking the file names into the executables, because right now Gdb is basically looking for a library called libpthread.so.1, I think, and that's what it's looking for. You've got this file name kind of cooked into Gdb there. And tools can also say that if they find these introspection functions, if they find these debug functions loaded into the application, then they can imply that the application is using those functions. So if you find a bunch of infinity functions that do thread debugging, then you can imply that the application is using threads. So you might have to handle that somehow. And this also works really nicely with static linking, because if as long as the kind of introspection functions are built correctly into the library, then when you statically link your library with, when you statically link your application with whatever libpthread, then you also get the debug functions end up inside the static executable. So wherever the debugger or the tool finds the functions is kind of irrelevant to it, as long as it finds them.
It only works if the infinity stuff is in the same object file as
Yeah, I had to
stuff.
squiggle it a bit to make that happen, but yeah. Yeah, it made the build a little bit, the glibc build a little bit uglier than I wanted, but it's kind of it does work. So yeah, if you want further pictures, this is kind of a picture of what it looks like now. So we're kind of now at the slide which should have been the first slide, but it isn't. What is Infinity? It's a platform-independent system for executables and shared libraries to expose functionalities to debug, monitoring, and analysis tooling. And the kind of components of the system is there's a note compiler to compile the actual functions into from some kind of easy-ish source language into their kind of encoded form. There's a tester, so you can actually write unit tests for these the functions, which is important because the kind of failure mode of them is late. The kind of discovery of failure is late because glibc or libpthread works fine if the notes are broken. The only time you actually spot this is in debugging. So you could potentially ship a glibc with broken thread debugging notes, and you wouldn't find that out until someone actually tried to debug it. In which case, you could have this could be deployed on thousands or however many machines, and then you suddenly realize that none of them can use thread debugging. And the other main component is a client library that tools like Gdb and anything that wants to handle these notes can use. And kind of for the initial part of it, I focus on thread debugging, so the initial kind of deliverable, as well as these three kind of core components, is going to include thread debugging notes for glibc and some Gdb integration, so that there's kind of there's a set of notes that are actually used for something, and there's something that actually uses them. And mm-hmm. Yeah, if somebody for whatever reason wrote their own application that had their own threading system, then they could have they could put Infinity notes in their application, and as long as they followed the same API as the ABI as what the debugger or the tool is expecting, then they should just work.
Yeah, it's a tools issue, right? So the DSO that you're writing, if it has its own thingamajigger, then it needs to expose the API that the tooling is expecting in order to understand the introspection of those other objects. And if it's threads and you want it to look like the way Gdb is going to work, then you have to provide the same libthreaddb APIs in Infinity notes so that your debugger using the client library can actually understand them. or tool, because it could be a process agent, for example, that's roaming an HPC cluster doing process monitoring and attaching to processes throughout a massive cluster. And then every time it attaches to a process, really could be using infinity nodes rather than having to try to guess what that node is running in terms of libthreaddb or whatever else it has.
Cool. Yeah, so I've got a little slide of just some kind of potential uses for this. Thread debugging, obviously, is what it started off as. Also, accessing Runtime Linker internals is something that GDB especially needs. Solaris and possibly others have a very similar library to libthreaddb called librtldb, which works in the same way, so it has the same problems. So my second target would be putting notes in the in glibc's Runtime Linker so that GDB can then access multiple namespaces and support code that uses DLM open.
Debug audit libraries today.
Okay.
Right. Without this, we can't. Like the audit libraries are hidden to the debugger. It doesn't see them because they're in an alternate namespace.
Okay. I did not know.
Not just for more features, but for plain features. Potential uses, solib.c can die.
Mm-hmm.
Would be great because that's the part of GDB that deals with looking up the dynamic linker data structures, which is, the data structures it deals with have been more stable for 30 years than the pthread data structures, but it still has the fundamental problem of baked-in knowledge or needing something like the RTLD, which has all the same problems as pthread.
Yeah. And
that code's just horrible. Being able to get rid of it these days.
So OpenMP is another use. OpenMP has this library OPMD, which does basically what libthreaddb does. It's a library for debuggers to access the internals of OpenMP, figure out what the program is doing, and again that works in the same way, has the same problems. Frank pointed me at this one the other day. Clang has address sanitizer and thread sanitizer passes that are currently doing some kind of they know structure offsets inside the library so that they can check these things. But this is something that you could trivially add kind of notes to get at that. And the final one is a little bit further off the field. It's pretty printers. Frank again asked me to. He started asking me loads of questions like, could you write a function like printf in this, which is not currently possible, but I know how to do it. It's kind of on the roadmap. So with that kind of groundwork put in, I'm just going to talk through kind of a pretty simple libthreaddb function, just to show.
Can I ask a question before you move on to that? So
Yep.
back of the page. So the existing pretty printers are in Python.
Yep.
So the maybe rigged audience question is, why didn't you use Python for this kind of introspection?
Mainly, the reason that we didn't really look at Python is the kind of weight of it. Like if we're debugging some program and say it's got 1 million threads, GDB at present can't handle that very well. But thinking about the future where this is going to be wanted, we don't really want to be like firing up a Python interpreter and dropping into the Python interpreter 1 million times when you attach to a process. So, and also for things like HPC clusters, you don't want. I think a lot of people who run HPC clusters are very sensitive about the amount of stuff, the amount of data that goes into what is on the compute nodes. So, if I was to suggest that we should use this thing, but by the way, you have to install Python on all your HPC nodes, then there would be pushback.
Not that I'm in favor of subtracting Python, but that's not really a problem because Python is only interpreted on the debugger side,
Mm-hmm.
target side, but also not their uses other than GDB.
Mhm.
and also pretty printing. And those are two separate things.
Yeah.
Where it makes sense to have, something like Python for how you print them is just a UI kind of issue. But for understanding the data structures, you really want that to be a separate piece, and you want it to be usable by other tools. You want to be able to say, right, system cat probes that can use something like Infinity to figure out how to iterate over a container, and then access elements in a container programmatically for a purpose other than just pretty code.
Yeah. I would say I'm not about to propose that we immediately kind of replace pretty printers. It's more that the kind of question was asked, and I wanted to make sure that if someone wanted to do that, there wasn't anything kind of in the way.
Well, but if the pretty printers could access via a Python interface the Infinity Note library, couldn't they just use it to iterate over the things and then do the printing part? So the pretty printers then get split in two, and they end up using Infinity to do the parsing or the API from the client library.
Is to be done this way, and that is something where you really want it done in a not literally declared, but something other than here's a Python code to run.
Yeah.
And it's very useful to separate those two concerns.
Yeah.
And like I said, you want those data structure access for things that today the only outside dropping of, for example, standard data structure we have is for pretty printing. But if you separated the grokking the data structure from the pretty printing, then you could use the grokking in all sorts of other programmatic ways.
Yeah. Do you have a question?
I think my question is just
Okay.
So you mentioned the pretty print state. So for example, if you say we're trying to debug a scripting language like Python itself or Lua,
Mhm.
would the Infinity function allow you to express the internal scripting language data structures to the debugger? So GDB could be made aware of your internal data structures in your actual library.
Yeah.
It might be really interesting and laid out in a funny way.
Yeah. Yeah.
Where you're just going to see a block of memory in your debugger, but really it's actually, I don't know, a hash table in Lua or something.
Yeah, that should be possible. I mean, I'd like it to be. If it isn't, then I would want to make it possible. Okay, I'm just going to quickly walk through one of the functions inside libthreaddb, so you can you can just see the kind of thing that's in there. And this is a really simple one, because all it does is a couple of checks, and then it hands off to another function which does a lot more complicated stuff. I've also had to strip all the comments out to make it fit on, which isn't ideal. But basically what it's doing, this function is getting the address of this symbol, a _stack user, from the inferior. It's treating it as a structure and accessing the next field inside that. And then it's checking to see if it's null. If it isn't, it's doing some stuff. Or if it is null, sorry, it's doing some stuff. And if it isn't, it's going on to a different thing. And this is I kind of really wanted to explain why this kind of stuff sort of has to be done programmatically. It's quite hard to express in any kind of descriptive form, because what this is actually doing, it's checking to see if libpthread is initialized, because you can interrupt a process really early in startup when it's all linked to libpthread, but it hasn't the process hasn't even really got going yet. So you still want to be able to debug this program. And so what libthreaddb does is it's looking. The only reason it's looking at this list is because by the time this list is initialized, you know that libpthread is initialized far enough to operate normally. So if this value it reads out is null, then it's basically saying libpthread isn't initialized. But at this point, then there should only be one thread. So as long as the caller is asking for information about this one single thread, then we can cope. So it returns a dummy value as 0 thread descriptor, which then other pieces of libthreaddb handle. So all of the a fair few of the libthreaddb functions are actually doing things like you pass them a thread descriptor, and it's saying, well, if this thread descriptor is null, I'm going to do this one thing. If this thread descriptor is not null, then I'm going to do this other thing, which is what happens when it's kind of the normal case. So what this looks like in kind of infinity source code, it's much the same thing. Accessing this piece of memory, you're doing one thing if it's if libpthread's not initialized, you're doing another thing if libpthread is initialized. The notes themselves have a name which is kind of split into a kind of namespace and an actual name, which I sort of borrowed from SystemTap. It seemed kind of useful. It's the kind of representation of the code is dwarf operation language, dwarf bytecode. So it has the kind of the same kind of layout. It's a stack-based language. This function has one argument, which is expecting to find pushed onto the stack by the caller. There is kind of, I'm not a compiler guy, so this stuff is, the actual compiler that I've written is more of a helpful assembler. It kind of has some optimizations. It does check the stack at every stage to make sure it's kind of what is allowed in the kind of note specification, but it won't lay out the stack for you. It doesn't track value liveness and stuff. So I'm kind of hoping that at some point someone's going to be called to write infinity notes, and they also know about compilers, and they're just going to go around and write this bit for me, because it's something I'd really like to have done, but I didn't have a spare year to figure out how to write a real compiler.
So is there a reason why the namespace is thread first and then you use libpthread?
I've kind of made a little separation between the kind of external ABI of the notes and the internal ABI, and the kind of ABI that the tooling is going to expect is kind of generic stuff. So I've called that part of the ABI is called thread. That namespace is thread, and the debuggers are going to access that. There's kind of a kind of convention. This function here that it's calling, I've kind of made a convention that if a function name has if the actual name part of the function is double underscore, then no client should call it directly. That kind of marks it out as an internal function. There's nothing to stop it, but it's just like, don't do this because.
Yeah, it's a libpthread internal lookup of the interface.
Yeah, this is a libpthread. This is like a libpthread specific internal function, and this one is an external thing that a tool can use. I'm going to show you another infinity function quickly. This is mainly because I want to show you a test case, and the test case for the previous function is pretty massive. So this one is a really simple. This is a really simple note that basically does two things. It calls one function, and then it calls another with the argument that it got back from the first one. So this function kind of has. This function has. You can see some of the stack manipulation. I want to get rid of rot and swap and rot again. This is all the kind of author of the author of the note has to manage this at present. But the only real thing to note in this particular example is this function calls two functions. This one. Oh, a little thing I actually meant to mention before is this. This first call is actually a call into the runtime linker. The glibc's libthreaddb is actually it's kind of nominally tied to libpthread, but it's also looking into runtime linker structures. So, and it's not doing any kind of there's no kind of version check there. There's no check to see if the runtime linker that you're actually using in your program is the one that the libpthread and the libthreaddb that you're using is built with. I know that's not a supported configuration for glibc, but it's also something that people are probably doing while they're testing. So the way Infinity's laid out makes it kind of work quite gracefully. So if you happen to be using a libpthread with thread debug notes and a runtime linker that didn't have thread debug notes, then any function that called the notes that weren't there just doesn't appear, so your tool doesn't see them.
I'm confused. So the infinity functions can call other infinity functions and inferior functions? Or
Not inferior functions.
also,
That
Yeah.
RTLD, link map TLS mod ID, is a call into LD's infinity function.
Yeah.
Because it needs to be interpreted as well.
Yeah.
So it's not a target inferior function that would
And
wreck your inferior state.
get TLS base is a local function.
Yeah, it's that one doesn't have the namespace on it, so it has the same namespace as that. So there's these kind of follow. There's two libthreadDB functions. One of them is get TLS base. One of them is get TLS address. And this is the libthreadDB function does the same. It just calls back into the other one, which is the big one that does all the work. They're executed by the tool, so they're in so in the
Could
debugger.
be host, but it doesn't have to be.
And something maybe useful to point out is that this is a system where that works whole core follow-up.
Pardon?
Right.
Yeah, yeah.
So, which implies that you can't ever be calling any inferior functions getting things done.
No.
Don't necessarily have inferior customers.
Yeah, that's right. It's this can easily work on core files as well. So all the execution of the notes and all things like fetching registers, all the stuff that's like fetching registers, fetching memory. That's all done by the tool. Nothing ever happens in the inferior at present. Okay, so this is an infinity function that basically calls two functions. That's its kind of the body of it. And this is kind of a test case for it. It's a function that has no flow, so it only really runs it through once with a set of dummy values. It stubs out both of the other infinity notes that are going to be called and says you should be called with this as your argument and this is your return value. And this one here, you're going to be called with these as your arguments and these are your return values. And it executes the note, it checks that what happened, it checks that these functions are called, it checks that they were called with the correct arguments. Obviously the test suite has got, or the tester itself has got, has the capability to kind of implement more functions. This is kind of just a common pattern that, this is a common pattern, but if you wanted to represent another note that did something more complicated than just get a value and return another value, you can do that. And the test suite also has the ability to kind of lay out a dummy memory so that you can, if you're testing something that say walks a list of threads, then it has stuff to help you lay out a list of threads in memory so that then you can walk them.
what are those numbers at the last line?
They were just dummy values, just something to that particular note is just calling certain other functions with certain other values. So it's checking that the so this one is going to be called with a thread descriptor, a link map address, and an offset. So it's checking that I think this one is expecting to you give it. This note is just access the TLS mod ID from this link map, so it's expecting to be called with the link map. So what the test is saying is whatever the link map argument to this note is should be the link map argument to that note, and so that kind of flows in like this is going to return a mod ID, which is then one of the arguments to this note. So then the next one is checking that the mod ID that the mod ID that this accessor returned is what is passed as the mod ID argument of this note.
So this must be relative as a specific TLS variable. Not using different TLS variable. You have to rewrite this.
Yeah. I mean, this is like a note from glibc. This is glibc's get TLS address note. So it's kind of encoded in glibc specific information into this function. So yeah, you would have to rewrite. You would have to write whatever you need for your for your implementation. The current status of this all, the note compiler is basically complete. It's got very good tests, but it needs documenting. The unit tester is, again, it's complete. It needs more tests and it needs some documentation. The client library is complete, but it needs documentation and a lot more tests. There's kind of a pattern here. The pthread notes that GDB needs in glibc are all complete. And I say the ones that GDB needs because libthread has, I should have counted it, libthread has quite a large number of functions that it exports, and very few of them are used by GDB. GDB only uses 5, so I've only implemented those 5. Because of the way this all works, you can just implement them piecemeal. So if other people want other libthreadDB functions implemented, then they can go and write them. And yeah, most of these notes have tests, but I need to document the API. GDB integration is all basically future work. What I've kind of done for now is I've got a really kind of hacky libthreadDB implementation that uses infinity notes instead of how it worked before, so you can test. So I can try all this stuff out with basically unmodified GDB until I actually get to do the next part.
But for the OMP, for the
Yeah, that's
OMPD, that's what we're going to have to do, right? OMPD is going to have to be a library, and then the back end is all going to be infinity.
Okay.
Because it has to match the standard.
Yeah, but the debugger then can skip it.
Okay.
Yeah.
Oh, well, I guess there's nothing stopping having a parallel implementation. Like if there is an OMPD library already written, then there's nothing that says this needs to be thrown away.
But for other tooling that knows about OMPD and is trying to follow the standard, you need to provide them with an OMPD DSO, but the back end is always just going to be infinity. We'll never have written hopefully we'll never have written an OMPD that did anything else.
Okay. And yeah, just a little, I'm going to show you a little demo. It's nothing, oh, hello. So I've got on here, come on. Oh, I don't know. So I've got on here a glibc built with thread debug notes. Inside the libix is the client library. Can you all see that okay? Is that too small? So I've got a libix is the client library, and it has inside it a little script to build a couple of examples with whatever glibc you choose to use. So you build that. You can look inside it, and you can see the actual notes. I don't have I haven't done the readelf part of it yet, so you just get a bunch of these unknown note types. The actual size of all the notes that GDB needs to do kind of full thread debugging is there, like OX688, which is I think about 1600 bytes. So
each function is a single node.
Yeah, each function comes out as a single note. Yep.
And they're not allocatable, right? So
No.
They're only disk size.
Yeah, it's only disk size as well. These are.
So they really are note sections.
They are note sections. That's why they're in. I should really be calling them infinity functions, just to make it clear that that's what they are. Each note is a function, and I try really hard to say infinity functions, but I always end up calling them notes because history. So okay. So if I run this little thing, then I've now got a process 3089, which is it's got 2 threads. They've got a TLS variable, and they should have different values. So if I run I've already forgotten the number. 3089. So if I run GDB on if I run GDB, it looks basically exactly the same, except it has this giant banner, which to kind of warn people not to be using this stuff. It's run a little self-test, which is what it's done is iterate. It's actually called some notes. It's iterated over the list of threads and checked that what the LWP ID of the note of the threads it's found matches the LWP ID that it then gets back if it asks for it. And this is so yeah, you can do like regular. I'm going to make that a bit bigger. You can do like regular info threads. You can see the list of them. You can see the TLS variable in this one is that. And you can access the TLS variable in that. So this is all, yeah, this is all done with notes, and you can run this all with like debug tracing if you like, so you can see. Did I say it was 309? Sorry.
It claims to be using libthread.
It is, but it's a generic libthread whose backend is infinity.
Yeah. So if you.
That's the quick way to hack
And it
it.
just reads out the nodes and
Runs them and interprets them.
Yeah. So if you look at them.
Don't throw this away so that we can use it.
Don't throw it away.
So yeah, this is all kind of in GitLab, so you can check it out and have a look. This little line here, what that's doing is telling libthreaddb. What this is doing is telling GDB when you're looking for libthreaddb, this is the directory you're looking for it in. So rather than using the system libthreaddb, it's using the one that.
So which means that libthreaddb will then be shipped in GDB, is it?
Well, at the moment, it's kind of an example, and
It doesn't need anything from.
it's actually, I mean, this example is kind of doing some pretty hacky stuff. It won't work in all situations that that regular GDB or the regular libthreaddb will work. It won't. So it's expecting to find a running process basically, or a core file that's referencing files on your file system. It doesn't work for things like that. So if we were actually to do, if you actually wanted to do like a libthreaddb or an OPMD library, there would have to be at least one extra proc service call added to the interface to allow GDB to get the notes or something like that. But what was I doing? Oh yeah, this stuff's all got like tracing in it as well, so you can. I'm going to shrink that. I'll make it bigger again in a second. Yeah, so you can like run this stuff, and you can actually see. You can get like traces of this stuff if you trying to debug it. This is maybe only useful for me, but you've got like this is the note that's being executed. This is the address in the ELF. This is the kind of offset in libpthread.so that it's currently executing. These are all the bytecodes that's going through, and the stuff that's gone off the edge of the screen is kind of the top 2 slots in the stack.
Have you extended the dwarf expression things for IXX of DREX?
So how do you encode them, for instance?
So what I've had to do, I've had to add a couple of extra instructions for things like calling, and because the dwarf operation namespace is pretty, it's got like 16 user slots in the end. So what I've done is I've picked one of them and used that as a wide code. So any kind of infinity things are in that one, and can't actually see any in there. All the ones that are DW op are standard dwarf opcodes. They're completely as they are everywhere else.
So you don't want to use the ref size, for instance, and to use something else?
No, the ones that have got IX in them are kind of internal. They've kind of been rewritten to suit the interpreter.
But if it's just the reference and you unsigned integer of 64-bit, and you could use deriv size. And well,
You can. I can't.
there's the in var5 there's the type stack.
Okay.
So you could use that.
Okay. I'll have a look. There is. I know about deriv size, but there is a reason I stopped using it. I can't remember that reason right now. So, but yeah, there's 4 or 5 extra instructions at the moment. Is all that's needed, and a lot of things in the kind of encoded form of the notes. I've used LEB 128 for all encodings, and a few things like the wide code of this thing. I picked a thing that said basically if this one particular bit in this is set, then that's a system one and you can't use it. If this bit is clear, then it's a user one. So the kind of number space is split in between system user. So there's kind of an infinite number of user bytecodes if you want, and there's an infinite number of system bytecodes. So you can always find, if you're writing your own interpreter, there's like a clearly defined set of numbers that you can use to put your own codes in if that suits your implementation. And that's kind of me done. There's a website, infinitynotes.org, which has got some documentation. I've kind of been laying it out in a wiki just to kind of get it out there. It's not in any kind of final form, and it's not complete. There's links to a mailing list on there that if you're interested, please go and subscribe. Links to the repositories if you want to check this stuff out. There's also, I've kind of been doing snapshot releases. There's one so far, and there will be one kind of next week. I was aiming to get one done for this presentation now, but it didn't happen. And kind of on there is a kind of, I'll show you actually whilst I'm here. Is it going to work? Yeah, so somewhere on here is the page of the release. So it's got this. If you want to try this out, you can try this release. So you can wait a few days and try the next one. But it's got a page like how to build it, how to test it, all the things you can have a go on. So it's there's kind of a little bit to play with there if you want to have a look. Haha, I've lost my slides now. Anyway, and there's also on that Infinity Notes, there's a weekend roadmap with all the stuff that I've been trying to figure out. So if anyone wants to help, I've got a ton of little pieces that need doing, little and big pieces. So I can certainly, I'm certainly ready for help if anyone would like to do that. And aside from that, is there any more questions? Mm-hmm. They're not loaded, but they are there, so there's nothing stopping a process instrumenting itself with notes and accessing its own notes if that worked for whatever you were trying to do.
Okay, so this may be in a road section.
Yeah. I mean,
it's like the debugging framework.
Yeah.
They're not like, no, I was going to ask, probably related to that. You made a note section. What's the trade-off between doing that rather than make them in a newly named debug section, given you thought that they look debuggy to me?
So you want to get this out of the target binary and for previously the way.
when you go to the user base flag. Depends what you want to do. I mean, if you want to shrink the slides and stuff, then right. Yeah, I mean, I would hope that these notes are pretty small. I mean, obviously, where is it for?
But the problem is it's not just debug. The nodes could do any kind of introspection. So it's tooling, analysis, lifetime monitoring, profiling.
So,
you
I
know,
mean, it's true. It's true. I mean, I think it's sort of a bit of an arbitrary choice because it's the case that the mechanisms we have, like built to find your debugging code from your target binary, could be used to find this stuff too. I'm not sure that it matters too much one way or the other. This seems like a decision that could be taken.
I've certainly tried to keep them. I've tried to keep the notes basically as small as possible. I've paid quite a bit of attention to the kind of format of them to kind of really make them small, to make this kind of a non-issue. Like if the notes for thread debugging are 1.6K, so if that's kind of a really small percentage of the actual size of the file that it's in. So I'm hoping that. I'm sure there will be someone that will object, but I'm hoping not too many people would object.
So, if it's really a non-issue and really small, why not make them allocated so they get dumped in core files? You don't actually need to.
Again, it's kind of arbitrary. I used as my guide for this what GDB can do already, and GDB can't. Can't do thread debugging anyway without the files. So without the actual without the executable and shared library files, GDB can't actually do this anyway. So we would not gain anything at present. And if in the future someone has a use case where they want to be able to do thread debugging without the then they can make it allocatable. And so basically, while there is at the present time, there's no reason for them to be allocated, so I've left them unallocated, just to kind of save that bit of memory.
Is there any difficulty having them as separate symbols?
How do you mean?
As in, so you can have your debug symbol separate from your actual executable, you have your notes separate as well?
There's kind of I've not made any allowance for that so far.
Since they're ELF nodes, actually, you will get them in. There will be the way script and debug works is nodes are wind up kept in both files. So as it is now, you could well read them from a separate debug file already.
Is that okay?
So the function name is the string in the nodes, and the value is sequencing.
Yeah, let's see if I can get the slides back. Yes. Okay. So the way that you reference the note is kind of its name and its name with its namespace and a kind of a little short encoded form of its arguments, which like this one just has pointers and integers. That's all it has. But there's also you can also have functions in there as well, so they get a little bit more complicated because that's a function with its integers. So they can be quite. They could theoretically get quite long, but they.
So I take it that all functions are the same in the sense that a note says, here's my straight name, and then has the section code.
Mm-hmm.
And if you were concerned about absolutely minimizing things, that just in the same way as we have, local symbols, you could code organize it such that the only strings that actually appear in the final node are the API outer functions and the inner implementation functions.
Yeah.
Are just referenced, get turned into offsets into the node or whatever by the compiler.
Yeah. Again, from the notes that I've written so far, the actual a good part of the size of them is their own name and the names of other functions that they're calling. So that's something that's kind of on my
So it's fairly obvious how to
yeah.
how to do that, and it doesn't change the semantics of what
No,
you're doing.
no.
Except in the case of something like test code where you might want to get at it internally.
Yeah, I mean,
And then that would potentially get to the potentially if you did that to avoid the names being there, potentially then for test purposes and debugging purposes might want to have separate note debugging code that had names or source location.
yeah, line numbers.
That between
Um,
code and everything.
Yeah, I mean, I haven't really talked about it at all here, but the actual internal format of the notes, I tried to make it as kind of future-proof as possible. So they're all they're kind of, the notes are kind of chunked up, and they've got version numbers on each chunk. And when I've been kind of the parts of the specification that I have written, I've tried to be really clear about what the client should do if, say, a chunk is missing. So in this case, with the names, you would have notes that, say, didn't have a string table chunk, but they had something else, which was kind of, I don't know, a reference into a merged string table somewhere else or something like that. So it's I basically try to make it so that things can be incrementally improved without ever having to like throw everything away and end up with client libraries having to have multiple interpretation, sets of code to handle. This is a version 1, this is a version 2. No, I don't want to have that. I want to have like the kind of smallest possible bit of non-shared code as I can. So yeah, I haven't really covered it, but I've kind of thought about it.
So just to be clear, what's kind of the set of data types these notes can return?
So the data types is pointers, integers. There's one which is opaque, which is nothing. There's no nothing can touch it. It's always just it, and that's basically for.
So you can pass it back to another node.
The main reason for its existence is for the libthreaddb function that iterates over, or generally for functions that iterate over something and do a callback. You're going to have a callback, and there's going to be some value which comes from the tool, which is, I don't know, some structure that the tool is going to pass. So the kind of opaque type is basically for so that tools can pass something in and know that it's going to come out. Like you don't want to have in your tool, you don't want to allocate a block of memory and then have a note add something to that so it's a bit further along, because you don't want the note to be able to mess around with your.
So if you're trying to expose a complex data structure, then your nodes are going to have to be kind of fine-grained for each operation.
That's kind of.
You can use nodes to drill down until you have an individual kind of pointer or
A single thing.
value.
Or a group, like the if
That's similar to say what you would get if you want to inspect a structure in system map.
yeah,
Same thing with
if you look at like both of these notes that I showed you, they both have more than one return value, so that's kind of a feature of it. So if you were kind of getting a kind of group of values from a structure, then they could all come back in one accessor, but there is no kind of, I've not had any kind of, there's no kind of structure. There's no way to say this is a whole structure of these things. It's just you can return more than one value, but each one is a kind of atomic, as a pointer, an integer, or opaque, or function as well. Function is a kind of first-class type.
So if you return multiple values, you can actually return like a pretty printed version of the set data type.
Yeah, if you wanted.
For
I'm
the
trying to see how pretty printers could be.
Mhm. Yeah, yeah.
For the test cases, do you compile them into Infinity or Python or
So
the next like just interpret them?
the test cases, there's actually like a note testing library which then loads the loads whatever binaries you're going to be shipping. So it could be it could be libc.a, it could be libc.so, libpthread. You basically in the glibc make files, it just says load these load these built binaries and run these tests on them. And at present, the tester has like a Python interpreter, which then interprets the notes, and then comes back out into the test suite, and that checks what happened.
This is Python.
This is Python.
Can you go to the last slide?
This
So I
one?
suppose this multi code will be evaluated.
Yeah, we'll buy a client library that GDB will link to, but in.
So for example, the call RTLD
Mhm.
link map TLS. What is the function in the target select?
No, this is another infinity note. This is another note function.
All of them are the infinity.
Yeah. Yeah. It can't, like somebody was talking about before, because we might be debugging a core file, you can't really call inferior functions. So. Yeah, exactly.
And that's part of the security benefit. If you call an untrusted, if you're debugging an untrusted binary in a container, and you're outside of the container, you want to still be able to pull it up and inspect some pieces of it, or a core file or something else, without having to load a container target libthreaddb.so into your own into your own execution in process image and run things in there from the thing you don't trust.
I'm definitely one of the things. I have been like kind of thinking about security on this, but I'm not a completely security focused person. So if anyone has a particular interest in the security of this, I'm very, very open to discussing this and bouncing some ideas around.
So I have one related question here, but it's sort of, if you have some tool, be it GDB or something else that debugs in some way, whether it's remote or in container or whatnot, it has some processes and lots of stuff loaded. So all of these things can have such infinity nodes.
Yep.
In a library to be related to anywhere. So how does your support library that the tool is linking things, how does it sort of get at that node, at these nodes? How does it know? Does the tool have to provide collector nodes, provide the
Yes.
library?
Yes. Yes. I'm kind of thinking from the context of that GDB has already loaded all of the ELF. It's already passed it. It's already got all the notes. It's already got all the note sections kind of split out, so it can, like something like GDB can easily pass, just pass the specific notes that it wants. I can see that.
But I mean, if a node calls other nodes, you can't pass just one node because you have.
Okay, so the kind of client library maintains a context, which is the complete set of notes that it's using and some other stuff. So your tool like GDB or whatever would create one of these contexts and add all the notes it finds to the context, and then that makes the kind of and then the kind of outer view of the context is any notes which can be called. So if a note calls another note but that's not loaded, then that doesn't appear in the view. So so say for example you've loaded the thread notes, but you haven't loaded the runtime linker notes, and they're not in the context, so that any thread note, the TLS thread notes which reference the runtime linker notes, don't appear. So in that case, your tool is going to see a context which has some but not all of the thread debugging notes. So it can then maybe infer that, okay, from however I'm running, I can do things like iterate over threads, and I can map LWPs to descriptors, but I can't give you TLS values because that's not visible to me right now.
We have to stop there. I'm afraid we run over time. There's men with tea outside waiting to bring it in. Thank you very much, gang.
Thank you.